Hi Pam, I love you and miss you. I miss all your positivity every day. This is the problem that you sent to me, and so I'm going to try to work this out without making any big mistakes. If I do, I'm just going to go back and fix it. So this integration, of course, there's a lot more integration techniques than what we learned in AB. And so this is a BC technique called trigonometric substitution. If you want some help from the book, 8.4, section 8.4 is great. And right on the front page, you kind of have everything you need here. But of course, I don't like to always go by formulas. So let's take a look at this. Notice if I tried to make my u x squared plus 4, that that would mean that my du would be 2x, and I don't see that here. Notice if I tried to make the whole denominator u, like I was thinking a natural log situation, when I do my du, I'm going to have way too much going on there. So, and obviously a division isn't going to work for us. So this is called not just a u substitution, but a trigonometric substitution. And I believe that it would be tangent, some form of tangent. And here's why. Is when you take a look here, this x squared plus 4, this looks like an arctangent situation, right? But I would need a 1 here, right? Notice also that if I just cover up the cubed, that this is the square root of x squared plus 4, which looks to me like a Pythagorean theorem that someone was trying to find the hypotenuse. They squared a side, squared another side, by the way, which would have been a length of 2. And so I think what I need is trigonometric substitution. So what I'm going to do is I am going to make my x not just tangent of u, because if I put tangent here, right, that would be tangent squared plus 4. Hey, if I had tangent squared plus 1, that'd be nice. That's secant squared, right? That might work for us. And so this 4, I really am going to want to be a 1 eventually. So that means that I'm going to put a 2 on my tangent u, because when I square 2 tangent u, I'll have 4 tangent u, and now I can factor out that 4. Okay, so that would make our dx then is going to be a 2 secant squared u du. So let's see, you may already see this, how well this is going to work out now, okay? And so I'm going to go ahead and substitute in u's. Here we go. First of all, right here for the x, I'm going to put a 2 tangent u squared plus 4, double parentheses, don't want to lose that 3/2 right there, okay? This 1 dx, I'm going to replace with a 2 secant squared u du. Notice then what's happening, this might really help us because we know the derivative of tangent is secant squared, so I think this might help us, but it's actually even better than that. Okay, so the next thing I'm going to do is I'm just going to factor out some constants so I don't have so much to integrate. So I'm going to factor the 2 from the numerator, and I'm going to have secant squared u. Now I'm going to start doing a lot of work here with the denominator, and I'm going to try to do that step by step to really help you. So notice all I'm doing right now, the only difference here is I am just going to square 2 tangent u. There it is. Let's not forget our exponent of 3/2. Now, just going to come a little lower here, not changing the numerator. There we go. I am going to factor a 4, but still keep it within parentheses. This is looking really good here, isn't it? So notice all I did here was factor the 4 from the tangent squared and the 1. It is still, the 3/2 is still being applied to that 4. One more before I go up to the other side. Oh, I forgot my u there. There we go. Okay, so I can actually do 4 to the 3/2 and tangent squared u plus 1 separately, right, to the 3 halves, right? And so by our exponent rules. How's that look so far? Here we go. Let's come on up over here. Okay, notice then that 4 to the 3 halves, when I take the square root of 4, that is 2, and when I cube that, that is 8. So this is actually an 8 right here. So I have 2 8s, secant squared u, forgot my du there, Pam, can't forget my du, tangent squared u plus 1. You may already be sitting there going, oh, I see what's going to happen. Take a look here, Pythagorean identity. We know what tangent squared u plus 1 is. It's secant squared. And of course, this is a 1/4 we have out front. All right, so we have secant squared u in the numerator, and in the denominator, we have, this is secant squared right here to the 3 halves. There we go. That's looking pretty good, isn't it? All right. Let's take a look here. Let's carry that 1/4. Notice that when the bases are the same and they are being divided, that we subtract the exponents. So that is going to leave me with the base is secant squared u and 1 minus 3 halves. That's going to leave me with a 1/2, right, for an exponent in the denominator. Now when we come up, just bringing along that 1/4. And of course, here's squared, here's the square root, and so I have 1 over secant. Isn't that amazing? 1 over secant u, how nicely that's working out, du. And of course, the reciprocal of secant is cosine of u. Right? Now we know how to do this. This is 1/4. Of course, the integration of cosine of u is sine of u plus c. Here we go. So we did actually integrate. Isn't that crazy and cool how that worked out? Now, here's our problem though. We need this in terms of x. We had x's here. Now we have u's. And when I try to go back and substitute, I'm like, oh boy, what am I going to do? I have this in terms of x. So let's work this out in red a little bit right here. So again, it's not so much the calculus, it's the algebra. Okay, I'm going to divide both sides by 2. All right, but I need that u alone. Notice that this is tangent of some angle is x over 2. So I am going to rewrite this as, if I do inverse tangent of x over 2, I get the angle. Right? Going way back to our pre-calculus. So now I can do this substitution right here. I know what u is. So it's 1/4 sine of inverse tangent x over 2 plus c. Now you may say, am I done? Technically that would be right, but it's not really. I want you to see when you found the answer, you're like, well, their answer doesn't look anything like this, so what are we gonna do? So what we need to do here, Pam, I'm gonna come on up over here and let's switch back to, let me go back to, let's do black. I am gonna draw a picture of inverse tangent of x over 2, okay? So here's what I'm gonna do. Here is my angle u, and it says that the actual value of tangent is x over 2, opposite over adjacent. So if you notice here in this picture, you would tell me that tangent, you probably can't see that on. Can you see that, Doug, when you're recording?
Yeah.
Oh, way over here. Tangent of u, you would tell me is x over 2. Right? But isn't it true then that inverse tangent of x over 2 is u in this picture? Right? Isn't that a picture of that? Now, using the Pythagorean theorem, I'm going to square one leg, plus I'm going to square the other leg. I'm going to add them up and take the square root, and that is the length of the hypotenuse. So notice right here that this was u, right? Well, now I'm saying then, well, what is sine of u? Oh, I can see from my picture what sine of u is now. Here's my 1/4, and when I look at my picture, sine of u is opposite over the hypotenuse. There we go, and plus c. And that's how they give a final answer that looks like that. I hope that that worked for you. If it didn't, let's start chatting. Thank you so much, sweetie. Love you and miss you.